For the final section of Chapter 7, Solving Linear Systems, we will be solving linear systems of linear inequalities. If you recall, a linear inequality is graphed much the same way that you would graph an equation. However, we either dash the line or we make it solid, and we have to shade one side of the line. So for our vocabulary today, we have system of linear inequalities. A system of linear inequalities in two variables consists of two or more linear inequalities in the same variables. The solution of a system of linear inequalities is an ordered pair that is a solution of each inequality in the system. For inequalities, there may be many ordered pairs that could be a solution to the inequality. It has to do with what lies in the shaded area. And finally, the graph of a system of linear inequalities is the graph of all solutions in the system, showing where the two shadings overlap. To graph a system of linear inequalities, the first step is to graph each inequality, keeping in mind whether the line is dashed or solid and the shading of that line. The second step is to find the intersection of the graph. When we graph a linear inequality, we shade, therefore the overlap is the shading that overlaps. Our first example, we're going to graph a system of three linear inequalities. When we do this graph, all three lines are going to help to create a triangular region of shaded overlapping areas. We're going to start with y is greater than 1. To graph this, we're going to graph the equation of y equals 1. And y equals 1 is a vertical or horizontal line that crosses the y-axis at 1. Since it's greater than, and not or equal to, it's going to be dashed. So I just take my eraser and dash it. So we're going to shade the region above the line because it's greater than 1. So this area is shaded. For our second equation, x is less than or equal to 4, for an x equals equation, x equals 4, this would be a vertical line at 4 that crosses the x-axis at 4. This one's going to remain solid because it was or equal to, and we're going to shade the region on and to the left because it's less than, and going to the left is less. So we're going to shade this area. Now, I'm going to erase what has not overlapped thus far. These two areas have no overlapping. So far, what's left could be part of our answer. The last equation, 3y is less than 6x minus 6, I need to solve it for y. So 3y is less than 6x minus 6. Divide both sides by 3. 3's cancel out. And that's going to leave you with y is less than, that is 2x minus 2. To graph this, you could put it in your calculator as y equals 2x minus 2, but it just has a y-intercept of negative 2 and a slope of 2, meaning we'll go up 2 over 1, up 2 over 1, up 2 over 1, connecting the dots. And we're going to shade the region below because it is less than. If you're not sure what area to shade, you can always test a point. Like if you tested 0, 0, which is not on that line, but you tested it in the equation, you would get that 0 is less than a negative 2, and that's false. And when it's false, you shade the opposite side. So it's going to be shaded below. Now again, I'm going to erase the areas that don't overlap. Now I can erase this area because it didn't overlap in black. And so our answer is this shaded area, which is a triangle. For our checkpoints, number 1 just has 2 linear inequalities that we're going to graph. So for number 1, let's solve the first one for y. That's going to leave me with y is less than or equal to 5 minus x. To graph that, that's going to have a y-intercept of 5 and a slope of a negative 1, meaning we're going to go down 1, right 1, down 1, right 1, down 1, right 1. This is going to be a solid line because it's or equal to. And I'm going to test a point to decide where I'm going to shade. The easiest point to test is 0, 0. So when I plug in 0 for x and 0 for y, I get that 0 is less than or equal to 5 minus 0, which simplifies as 0 less than or equal to 5. And that is true. 0 is less than 5. When it's true, I shade the side of the line with 0, 0. For my second equation, it's already solved for y, so I just have to graph the equation. It's going to have a y-intercept of 3, it's right there, and a slope of 1, meaning I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. This is going to be a dashed line, because it's just less than. To decide what part of the graph to shade, I'm going to substitute in, again, the 0, 0. Is 0 less than or equal to 0 plus 3, which is 0 less than 3, and that's also true, meaning I'm going to shade the side with 0, 0, which is this side. And then I'm going to go ahead and erase the parts that did not overlap, because that's not going to be part of our solution. So your overlapping area is your answer to the inequality, the system of inequalities. And for number 2, we're not necessarily going to be looking at graphing a shaded region here, but there are 3 inequalities. We're going to start with graphing the first one, x is greater than 2. That is going to be a vertical line at negative 2, and it's going to be dashed. And we're going to shade to the right of that because it was greater than negative 2. So we're shading this side. Then we move on to y is less than or equal to 4. That is going to be a solid line, horizontal, that crosses the y-axis at 4. Since it's less than or equal to, we shade below it. If it helps, go ahead and erase what's not overlapping. And then let's graph the last equation. I do need to solve that one for y if you want to be able to put it into your calculator. So I'm going to move the 3x over here. That's going to leave me with 4y is less than or equal to 24 minus 3x, and then divide both sides by 4. 4's cancel out. You get y is less than or equal to 6 minus 3/4 x. So it's going to cross the y-axis at 6, which is up here, and it has a slope of negative 3 over 4. So I'm going to go down 3, right 4. And be careful because they are counting by 2's. So when I go down 3, right 4, it's going to put me about right here. We go down another 3, right 4, puts me right there. To connect those, that will be a solid line because it was less than or equal to. And to decide where to shade, we're going to take that 0, 0 point, just like we did in some of the previous ones. I'm going to plug in a 0 for x and for y. Those become 0. Is 0 less than or equal to 24? Yes. So I shade the side with 0, 0. And then I'm going to erase any area that I might have shaded that was not an overlapping area. And the shaded area, this is not shaded right here in blue. You have to be careful of that. This is a different looking shaded area. It was not part of the triangle that was created above it. It's actually everything below that triangle. And on our last page of notes, example 2, to write a system of linear inequalities, we can look at the graph that's shaded and come up with the equations from that. In inequality 1, one boundary line for the shaded region is y equals -2. That is this dashed line right here. That's how we will determine whether it's a less than or greater than. And it's shaded above. So we're looking at an above shaded dashed line. That's going to be y is greater than -2. And that takes care of the dashed line. Now let's look at inequality 2. This one has a slope of up 2 over 2, up 2 over 2, or you could think of it as up 1 over 1. It has a slope of 1. And it crosses the y-axis at a -1. So the equation would be y equals x minus 1. And because the shaded region is below and the line is solid, we'll make the inequality y is less than or equal to x minus 1. So the system of inequalities for the shaded region is y is greater than -2 and y is less than or equal to x minus 1. We have 2 checkpoints. We're going to write the system. Let's start with the vertical line. On the vertical line, equations that are vertical are going to be x equals, and it crosses at -1. So I'm going to take that equation and I'm going to turn it into an inequality. It's going to be x, and in this case it's going to be less than or equal to because the shading is to the left of the line, or it's going to be less than because it is dashed. Less than -1. So there's one inequality. For our second inequality, we're going to look at the other line, which crosses at 5, and it has a positive slope where we go up 2 over 1, so it has a slope of 2. So that would be y equals 2x plus 5. Since the area is shaded below it, that would be y is less than or equal to, because it's solid, 2x plus 5. And those are your 2 inequalities for that shaded area. And for the last one, again, we'll look at the vertical line first. That equation is x equals 2. Since the area is shaded to the right and is solid, we're going to say that x is greater than or equal to 2 for one inequality. And for the other dashed line, it has a negative slope. It crosses the y-axis at 5. And its slope, we go down 1. We're going to go from this point to, it looks like it crosses right at this point right here. So that's going down 5 and rise 6. So that would be a negative 5 over 6 for the slope. So it's y equals negative 5 over 6x plus 5. Since it's shaded below and is dashed, that's y is less than or equal to, y is less than negative 5 6x plus 5. And that concludes lesson 7.6.